So we're going to talk about dispersion. And what is dispersion? Well, we're dispersing the group of particles that are under study with the goal of making them so that the instrument can effectively identify them as individual particles as close as possible. What is the native size of the individual particles? And if your size distribution has particles, let's for example say from half a micron up to 100 microns, that's a broad distribution, but you would like to know that you have half micron particles in there, just like you would like to know you have 100 micron particles in there, as well as what's going to show up as the average, which might be something like 40 or 50 microns. So you have to realize that what you have is a distribution, unless you're dealing with a monodispersed sample, which is almost like one of our controls, where the distribution is very narrow. The breadth might cover only a few microns, or in the case of the low-end things, maybe some small number of nanometers difference from one end to the other. But it's really about trying to get that distribution as accurate as possible, so that you know what to expect from the behavior of the material. And that's really ultimately what the end user is concerned with. They really don't aesthetically care what the particle sizes are. It's what is the result of the particle sizing distribution to their end result product, whatever it is they're going to use this preparation for. So one could say that accuracy of the individual particles is the premier goal, that is to know exactly what you do have there. But effectively, it really almost, in most cases, you do have a distribution of sizes, except in the most ideal conditions, and therefore accurately characterizing that distribution can be absolutely critical.